let me tell the origin story where it kind of came from. So JSON schema is obviously, so when you work with JSON primarily, then JSON schema is naturally the thing that people fall into and start using. And so did we. And we've been working on, so in standardization, we've been working on a standards suite, if you will, called X registry, which is schema registry, and also a registry for endpoint and message definitions, because we're building a messaging platform. And so schema registry is something you need for, if you have protocols like protobuf and Avro, you need to share schemas, because the point of these binary protocols is that you leave the schema stuff off the wire, and then you kind of share them out of band, and the schema registry is good for this. Of course, we're defining that as an JSON-based document format. So we needed to have our own schema. That's one use case. Inside of our platform, Microsoft Fabric, we want to have a typed experience. We need a way to kind of closely define what the structure of a stream is, because we're building effectively a data funnel, and that data funnel must be typed because the end of that data funnel is either a data lake or a database table. So I need to take documents and ultimately land them in columns and rows. And I need to do this in a way that I don't go and do the cheap cop-out of saying, oh, here's an index field, and then there's a dynamic field, and I'm just going to dump the data all in there. But it needs to be such that a query engine, and then in the end, something like Copilot can understand that structure. So I need to basically do a translation. I need to capture that information. At the same time, on the publisher side, I also want to have structured data. I need to go and capture that information. Real-time data pipelines, messaging-based data pipelines are really expensive to build, mostly because we lack a way to do metadata. And so that's the starting point where we started. And so the options that we had were really JSON schema and Avro, because there are many schema languages. The biggest problem with many of those schema languages is that people did write their own syntax, and you need to have a bespoke parser for them, and the library coverage is not so good. The nice thing about JSON schema is that it is JSON, and the nice thing about Avro schema is that it is JSON. So there's a quality to that. So that's where we started. And as we were getting serious about building tooling on top of JSON schema, we ran into the problem that everybody else is running into. If you look around, for instance, OpenAPI is leaning on JSON schema. You will not find any implementation of OpenAPI code generation which doesn't give up at some point, because JSON schema is good at defining the shape of a JSON document, but it's lousy as a data definition language. It's really a validation language. And then when you think about what people do with it, there are some patterns people have not formally agreed on, but everybody kind of does it. Like, how do you do inheritance or reuse of types? You create an object and then join that with an all of expression with another type. And then that defines a inheritance hierarchy. That's what many tools understand. There's no rule around this. There's no standard around this, but that's kind of just a convention. If you add a second type to that all clause, everything falls apart. It's like that with many constructs. Many tools just fall apart at undefined places. Creating a JSON, a relatively complex, because sometimes you need complex data structure, which will compile or which will translate into compilable code in several languages, even if you use the OpenAPI toolset, is enormously difficult. I was frustrated by this, because it's not a data definition language. It's a language that validates. It's good for that, but as a data definition language, it's not very good. So go Avro. We need to generate code, and we need to be able to drive tooling from the scheme. Avro has the advantage of being very well scoped, very self-contained. There's no external references. There's namespacing. There's all kinds of interesting constructs in there. And it's extensible to the point that you can make annotations, and the Avro tooling will not worry about those annotations. It's good at that. but it has some limitations, like its type system is limited by the binary serializer. It has other problems in that it can model things like inheritance, but there's a bunch of complex types that it can't model. We have then, and it has a absolutely abominable JSON serialization model. It's terrifying. So you might like the schema and you say, I can use this to go and describe my JSON documents. And then you read the way how they're defining how these schemas shall be translated or shall govern a JSON document, and you're like, no, you're not serious about this. So I have tried to go to the Avro project and say, hey, how about we create an alternate way of doing JSON serialization? But there's really nobody at home in the Avro project. Like, there's people who are maintaining it. There are people who are doing bug fixes. And they're doing great, grandiose work. But there's very little appetite to go and make big changes because that's causing a lot of work. They're okay with maintaining, okay with, bringing another language on, but making big changes, revolutionary things to Avro hard. So that's where we were. Basically, needed a schema language that is kind of has traction, at least in developer mindset, and then actually in also the mindset of LLMs. But Avro is kind of hard to fit everything into, and JSON schema just way too complicated.